Good evening, Year 11. I'm just going to go over some last minute bits of maths revision before your first maths paper tomorrow morning. This video is for higher tier maths. Just a reminder that your paper 1 exam will always be non-calculator, and that tomorrow morning the hub is going to be open from 7 AM if you want to come in and do some revision at school. There'll be lots of maths teachers around from about that time onwards, just to give you a little bit of support before you go into your exam in the morning. Obviously with maths, pretty much any topic can come up across any of the three papers. I've just listed here some very common non-calculated topics. There are some of these things that really do only make sense to come up on a non-calculated paper, like any sort of fraction operation question, or evaluating indices, or estimation, or surds. Those things really only can come up on non-calculated papers because with your calculator they obviously become very, very easy. I've just selected a few different topics to go through this evening to give you a little bit of a boost, a little bit of extra practice on some of these things. First one I wanted to look at was probability. Obviously there are many different types of probability question, but quite a common one if you look back over the last few years of exams is a probability table question. So the key with this question then is we need to recognise that all of those probabilities in that table have to add up to 1 because there's only blue, red and yellow cubes in the box. So if we're going to take a cube out of the box, those are only options, therefore this has to add up to 1. It does say that the number of red cubes and the number of yellow cubes are actually the same. So as we know that it all has to add up to 1, all we need to do is take away the 0.4 from 1 and then we can half that, and that's going to give us the probability of red and the probability of yellow, and then we can just fill the table in. 1 take away 0.4 is going to leave us with 0.6, divide that by 2 and we get 0.3, so we can pop 0.3 in both of those boxes there. That's going to give us the answer. Part B says that there are actually 24 blue cubes in the box, so it asks us to work out the total number of cubes in the box. Well, we know the probability of picking a blue cube is 0.4. So that's 0.4 of the total number. So 0.4, I'm going to call the total number x, and that equals 24. So I want to know what that total number is. I can just divide both sides, look, by 0.4. Remembering obviously this is a non-calculated paper, so we're going to have to use a non-calculator method to do this division by decimal. And a nice way to do that is just to get yourself an equivalent fraction where your denominator is no longer a decimal. So I'm just going to times that by 10. And whatever I've done to the denominator, I do have to do to the numerator. So we get 240 over 4. And 240 over 4 is a bit more obvious what the answer is going to be. 24 divided by 4 is 6, so 240 divided by 4 is 60. Obviously we could have done a bus stop if we needed to support ourselves through that, but that does give us our answer of 60. Here's a just a different version of the same question. You've got a table and then a follow-up question there, part B, about working out the number of blue cubes. If you want to pause the video here, have a go at that on some paper, and then unpause when you're ready to see the answers. Okay, here's the answer to this question then. I've snipped a bit of the mark scheme so we can have a look at that as well. So the first mark you would have got on this question is called a process mark, and that is for literally just doing this top bit here in our answer. We get a P1 mark there. And that could be seen through seeing the 0.4 as well, and then our accuracy mark comes in recognising that that is going to be 0.2, and you can see that I filled in 0.2 on those tables there. With part B, following that same method from the last page, different numbers obviously. It was 0.6 of our total is 21, so I was dividing by 0.6 and we're getting our first process mark here by doing 21 divided by 0.6, and we can see that here in my calculation and that gives me that first mark. Same process then, dividing by a decimal, times it by 10. That would give me the answer of 35. And there's our accuracy mark for that question. So 4 marks in total for that one. Surds then, just wanted to go over a few key points for surds. If we need to add these two surds together here in this question, then we need to make sure that they're both the same surd. It's kind of like when you do collecting like terms. I can't currently add those together because they're not like surds. We know the answer needs to be a root 3, so I think what we need to start with is the 27. We're going to simplify this surd then as much as we can. There are a few ways that you can go about simplifying surds, but a prime factor tree is always going to get you to the right answer if you're not sure. So that's what I'm going to do here. Root 27 we can split into root 3 times by root 9, and root 9 splits into root 3 times root 3. So we've got that root 27 is the same as root 3 times root 3 times root 3. We can pair up that pair of surds because root 3 times by root 3 just gives us 3. So we get 3 root 3. Therefore, root 3 plus root 27 is the same thing as root 3 plus 3 root 3. So again, if we're now collecting our like terms, I've got 1 root 3 plus 3 root 3. So altogether, that's 4 lots of root 3. So our answer for part A would be 4 root 3. Part B says express 1 over root 3 to the power of 5 in the form root b over c, where both b and c are integers. So the first thing I'm going to do is expand that bracket. I'm going to raise both of those things, my numerator and my denominator, to the power of 5. So I have 1 to the power of 5 over root 3, all to the power of 5. Well, 1 to the power of 5 is just going to give us 1. Think about what's happening when we raise something to the power of 5. It's like having root 3 times root 3 times root 3 times root 3 times root 3. Think about how many pairs you're going to have there. That's going to give us a pair of 3's. That's going to give us a pair of 3's. So 3 times 3 gives us 9. And that's still being times by this root 3 at the end. If we're going to give this in the correct form, then we need to rationalise our surd, which we can do just by multiplying by root 3, because we've got a single term in our denominator, not a sum of 2 terms, so we could just multiply through by that surd. That will give us root 3 in our numerator. In our denominator, we've got 9 times by root 3 times root 3. So 9 times by 3, and 9 times by 3 gives us 27. So our overall answer is root 3 over 27. Got a similar question for you here to have a little go out on some paper. Pause the video, and then when you're ready for the answers, unpause the video. Okay, so here is the first question. Again, I've put the mark scheme so we could just have a look at where those marks come from. Our first mark then is given for a method to use to simplify root 18. So we're going to get our first method mark over here for simplifying. Okay, and then our accuracy mark comes from getting the final answer at the end. So using our simplified surd and then collecting those surds together. And in part B, we can see again where those marks come from. Look, so we've got the first mark given for a method to simplify the power. So that is to get us to this point here. Okay, so I've raised 1 to the power of 9, and I've raised root 2 to the power of 9. And then the accuracy, another method mark for starting to rationalise. So actually showing this process of timesing by root 2 is going to be enough for that next method mark, and then an accuracy mark for our answer at the end there. Volume can quite often come up in a non-calculated paper. It will often be either an estimation question, which actually this one isn't, or your answer will be left in terms of pi. So having a look at this, we've got a solid shape made from a cone on top of a hemisphere. The height of the cone is 20 centimetres, the base of the cone has a diameter of 12 centimetres, and the hemisphere has a diameter of 12 centimetres as well. The total volume of the shape is k pi centimetres cubed, where k is an integer. Work out the value of k. So the only way we're going to be able to do that is by working out the volume of the cone and adding on the volume of the hemisphere. So I'm going to start with the cone. I know for the cone, my formula is 1/3 pi r squared h. I know that in this question h is 20 and my radius is going to be half that diameter, so it's going to be 6. So the volume is 1/3 times pi times 6 squared times 20. Okay, 6 squared is going to give me 36. 36 times by a third is just a third of 36, that's going to be 12. So I've got 12 times 20 times pi. 12 times 20 is going to be 240 pi centimetres cubed. We can do a similar thing now for our hemisphere. With our hemisphere then, that formula that we've been given is for a full sphere. So I don't actually want that, I want half of that. So I want half of 4/3 pi r cubed. And if I multiply that out, that's going to be 4/6 pi r cubed, which if I simplify that fraction is the same as 2/3 pi r cubed. So we've got our volume of that hemisphere is going to be 2/3 pi r cubed, and we've got that our radius is 6 centimetres. So substituting all of that in again then, we've got 2/3 times pi times 6 cubed. 6 cubed is 216, so we've got 2/3 times 216 times pi. So I'm just going to do a little bus stop now to do 216 divided by 3. So that's going to give us 72. And then we've got two lots of that, so that's 144 pi centimetres cubed. So the total volume is the cone plus the hemisphere. So 240 pi plus 144 pi. So altogether, that's 384 pi centimetres cubed. The question wants to know what k is, so k is 384. Here's one for you to have a go at then. If you pause the video, work it out on some paper, and then unpause when you're ready for the answer. Here's our answer then for that question, and again we've got the little mark scheme so we can have a little look at where all of those marks come from. Just going to scroll that down. So our first mark comes from working out the cone. It's actually the method for working out the cone, as you can see over here. So using the formula to find the volumes of the cone. Oh, and the hemisphere. Okay, so that's actually sort of attached to both of those processes. And then the second method mark is for a complete method to find the volume of the total shape. So you can see what they're sort of looking for in the calculations here, which is what we've got on both of our sides here again. And then adding those two things together, and then our accuracy mark at the end for recognising that it's the 1296. And that's where we're going to get our final mark for that question. Final one that I wanted to look at then was exact trig values. So you could be asked to do this within a triangle question. So they might be using a right angle triangle, you have to use SOHCAHTOA but without a calculator. Or you could get a question like this, where you're doing a calculation with your exact trig values. or you can even just be asked to state one of the exact trig values. One of the best ways to do that is just to generate those values, unless you have already memorised the table of all of those exact trig values. So I'm just going to run over that quickly with you here. You've got sine, you've got cos, you've got tan. We're going to have to know all of those for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And one of the easiest ways to do this is you just, in the first column for sine, you put 0, 1, 2, 3, 4. You put all of them over 2. And you square root all of the numerators only. Okay, you can then go through and simplify each of those. Square root of 0 over 2 is just 0. Square root of 1 over 2 is just a half. We can't simplify that next one or the next one, but over here, look, the square root of 4 is 2, so 2 over 2 is 1. Cos is exactly the same, just in the reverse order. So it goes 0 from this direction, then the 1/2, then the root 2 over 2, then the root 3 over 2, and then the 1. And then for tan, we need to remember that tan theta is just sine theta over cos theta. Okay, and I would say only 2 of these you really need to think about, because for this first one, look, 0 divided by 1, well, that's just going to be 0. For 45 degrees, you've got root 2 over 2 divided by root 2 over 2, or anything divided by itself is just 1. And for this last one, you've got 1 divided by 0, and anything divided by 0 is going to be undefined, so we don't get a value for tan of 90. So it's just the other two that we need to think about. For this one here, sine over cos, so it's 1/2 divided by root 3 over 2. Keep change flip, so 1/2 times 2 over root 3. Cross cancel, we get 1 over root 3. So it's 1 over root 3. If you rationalise that, that's root 3 over 3. Okay, and then we could do the same for this one. Root 3 over 2 divided by 1/2, which is root 3 over 2 times 2 over 1. Rationalising that, not rationalising, sorry, cross cancelling, we just get root 3. So this question asks us to do tan 30 times cos 30. So tan 30 is here. We could use either of those two versions for tan 30, and cos 30 is here. Okay, so we've got 1 over root 3 times root 3 over 2. If I cross cancel there, I'm just left with 1/2. So our final answer for that is 1/2. One for you to have a go at here, so try to reproduce that table of exact trig values and then work out the answer to this calculation. Unpause the video when you've got your answer and you want to see the answers. Here's the answers to this then. We've got our table reproduced, selecting the correct 2, and we get a method mark if we've got this one being root 3 and this one being 1/2. So the mark scheme does say you have to have both of those to get the first mark, and then we get our accuracy mark for actually doing the calculation correctly. So that's all that I wanted to go through in this video. What else could you do to prepare for your exams tomorrow? There's some websites on the screen that you can go onto and have a look for different types of things. Past papers, there's quite a few of those on Maths Genie and Revision Maths, Corbett Maths, Exam Q, and Maths Genie as well for sort of topic specific things. But practicing is the best way to make sure that you're fully prepared for your exam tomorrow. And good luck!